In this video, I want to show you a relation between the beta function and the gamma function, because I have used the relation between the beta and the gamma function last time. So I want to show you that these functions are indeed related. Let's start with the definition for gamma, the gamma function. Gamma of x is equal to an integral from 0 to infinity of alpha to the x minus 1 e to the minus alpha d alpha. Then we have the beta function. The beta function, which depends on two parameters instead of only one, a and b. And we have to integrate from 0 to 1, t to the a minus 1, and then we have 1 minus t to the b minus 1 dt. And let's consider the product of two gamma functions, gamma of x, gamma of y. We can rewrite this as integral from from 0 to infinity, integral from 0 to infinity of alpha 1 x minus 1 alpha 2 to the y minus 1 e to the minus alpha 1 minus alpha 2 d alpha 1 d alpha 2. And now let's change the variables in this double integral. We go from alpha 1 to z times t, and then we go from alpha 2 to z times 1 minus t. And so in order to find the transformation, so to find how this integral transforms, we need to find the Jacobian of the transformation. So we need to calculate d alpha 1 dz, which is equal to t. Then we have d alpha 1 dt, which is equal to z. And then we need d alpha 2 dz, which is equal to 1 minus t, d alpha 2 dt equal to minus z. And therefore we can rewrite the Jacobian that I can rewrite it in this form: d alpha 1 alpha 2 dzt. This is equal to, and we also need to calculate the absolute value of the Jacobian. So I'm going to put two bars to indicate that the first one here is the absolute value, and then we have the determinant tz 1 minus t minus z, and this is equal to the absolute value of minus z, which is equal to the absolute value of z, like this. Therefore, we can write this double integral here. Let me write gamma of x, gamma of y, and then we have integral from 0 to 1 here, integral from 0 to infinity. So you can see that z will go from 0 to infinity, whereas t should go from 0 to 1, because alpha 1 and alpha 2 range from 0 to infinity, but t should not exceed the value of 1, because we have 1 minus t here. So if t is larger than 1, alpha 2 will become negative if z is positive. So we know that t goes from 0 to 1. And then here we get z to the power x minus 1, t to the power x minus 1, and then we get z to the power y minus 1, and then we get 1 minus t to the power y minus 1. Then we get e to the minus zt minus z times 1 minus t. And then we get the absolute value of z, but it is just simply equal to z because z is positive, dz dt. But now we can rewrite this in the following manner. We can rewrite it as integral from 0 to infinity z to the x plus y minus 1 e to the minus z dz. Then we have integral from 0 to 1 t to the x minus 1, 1 minus t to the y minus 1 dt. And now you can easily see from their definitions that this is equal to gamma of x plus y times beta of xy. So all in all, we find the following formula. Beta of xy is equal to gamma of x times gamma of y divided by gamma of x plus y, which is a formula that we used in the last video when we calculated when we normalized, let's say, the Legendre polynomials.